Hello, good morning and welcome. You have joined the Technologist Track today, and this is the Advanced Innovation session. My name is Lucy Woodhead. I'm a software developer at GSK, but I'm also the community manager here for AI Tech North, and I am in a very lucky position and I get to collaborate with organisations from the North and further afield on AI. It's a real pleasure today to be hosting this session, and I have three amazing speakers lined up. First of which is Professor John McIntyre, who is the Pro-Vice-Chancellor of the University of Sunderland up in the North East. And today he'll be talking about AI applications and how it's a double-edged sword. So without further ado, I'm going to pass over to him and strap yourselves in, take some notes and enjoy the session. Thank you.
Hi, morning everybody. Great pleasure to talk to you all. And as colleagues said, I'm John McIntyre. I'm Pro-Vice-Chancellor at the University of Sunderland. I've been working in applied AI since the early 1990s. I did a doctorate in applied AI, and I've also been the editor-in-chief of a scientific journal called Neural Computing and Applications since 1996. And that's been an interesting vantage point, I think, over the last 30 years to see how AI is developing, applied AI is developing. And the development of AI, I think we all recognize, we're in a boom period of AI, both from a scientific and academic point of view. And the journal that I've just mentioned, Neural Computing Applications, this year will receive almost 4,000 submissions from around the world. That's 4,000 pieces of individual applied research that we take through peer review and hopefully publish. The exponential growth that we've seen in submissions to the journal, I think, is not just a reflection of the journal being a good journal, but it's a reflection of the work that's been done around the world. And what's interesting is, having watched that over the period since I took on the role, of how the breadth of applications has expanded, but also how the technology has grown. And I think when you look at that and you see how powerful the technology of AI has become, and how ubiquitous it has become, I think that gives it a really interesting kind of set of questions which emerge around where we're going with AI. I've seen applications of AI which as a technologist, as an applier of AI, which has really been my background, for which I can be very, very impressed in terms of the state of the technology, how clever the applications are, and how well done they are, and at the same time be very concerned about what the connotations and implications of those applications are. And it's that I really wanted to kind of explore this morning. Of course, we're in the middle of this extraordinary time with COVID-19, and it's natural, isn't it, that AI would be one of the tools we want to bring everything that we can to bear to try and beat back this virus and get back to our normal lives and recover the economy and recover the way we live. And early in the pandemic, applications of AI were being talked about and then developed, which might not always have been developed in the way that you would normally go through a rigorous process of ensuring, a bit like the development of vaccines, there was a whole conversation about making sure that they're both efficacious and safe. And some of the applications of AI in COVID-19 have been developed in ways as a kind of rush to judgment to get them out there, to get those applications available, which I think do cause some concern. What we've seen is applications which have been at the epidemiological end, big data models with AI technology embedded in them, which are being used as the decision support by politicians in this country and elsewhere to make fundamental choices about the way we live our lives, about life and death decisions, and about our economy. And colleagues will have seen, and the audience might have been involved and read about conversations around how robust those models really were. This is a new virus, and of course, basing models using AI, training AI on data from past experience, and then applying it to a completely new situation, carries with it the danger that the AI model becomes not robust in the face of of a new situation. And anyone who's worked in AI and worked in big data knows that training big data models with small amounts of data is a flawed proposition from the start. And I believe that some of the epidemiological modeling has not been robust, and there's been a whole conversation around how those models are being used in decision support by politicians. I think added to that, there's also the issue of how models, particularly in medicine and healthcare, have been developed, which I think at times have also caused some ethical and application concerns. I'll give you a couple of examples. Certainly, as we all understand, COVID is a terrible, terrible, deadly disease and badly affects the lungs. And when health systems have become overwhelmed, we've seen around the world terrible, terrible pictures in the early days of the pandemic coming from Italy. And we're seeing doctors desperately trying to kind of, treat patients and care for people in really bad condition. And what we've also seen is the co-opting of healthcare professionals, often young and inexperienced healthcare professionals, in to support the overall health system. And then the idea that AI can somehow also support those clinicians in this great fight against COVID. And one of the areas of applications, those who know about AI will know that one of the things AI does very well, can do very well, is pattern recognition. So looking at images and being able to recognize things from those images is something we can train AI to do very well. And that's an application we see in my journal a lot and is out there in use a lot. Training AI systems to look at lungs, images of lungs from various different types of scan, and then make triage decisions and diagnostic decisions on COVID patients has been something which is done, and certainly in the early days of COVID, became seen as a real boost to help clinicians dealing with this great pandemic. But what's beginning to emerge is that perhaps some of those applications weren't based on sound data, weren't necessarily given diagnostic decisions or diagnostic advice to clinicians, which were fully representative of the actual position of that patient. And then that leads you to AI being a tool being used, possibly by inexperienced clinicians against a disease they're not familiar with, making life and death decisions for patients, really on the basis of AI that's not necessarily robust. And I think anybody who works in AI, and indeed all of us in society, should be concerned about the rush to use AI in such situations when maybe the AI applications aren't as robust as we might think. And indeed, following on from that, from the original kind of diagnostic and triaging, we're also seeing AI systems being used for other parts of the healthcare process. So making a decision not only about whether or not this patient has COVID, what level of COVID, does this patient need to be hospitalized? Does this patient need to be transferred to ICU? Does this patient need to be ventilated and intubated? What kind of drugs would be best to give this patient? What kind of therapeutic treatments? So those are very, very, very profound decisions at the level of the individual. And being made not only by AI, of course, clinicians in the loop, but go back to that point about clinicians under great stress, dealing with massive problems in terms of resources, and often, dealing with a situation they've never seen before. And the AI tools being kind of perhaps too much of a crutch to lean on, and the possibility of decisions being made very much reliant on the AI rather than the AI being one of the things you would take into account. And I think that there have been examples of that all over the world. And I think that what all of that kind of encapsulates is an example where the possibility that AI is seen as a tool to fight the disease, and we all want that, but is then developed and rolled out so quickly that the efficacy and the safety of the AI is not necessarily tested to the level that it should be, and we would all want that. And the final thing I'll say around around COVID is also we've seen in this country that it's been a very, very troubled journey to try and get a track and trace system. there's been a lot of discussion around that, and I'm not going to go into all elements of that, but the AI components of that are also a worry in terms of what happens to that technology in the future. Not so much in track and trace now, but there are certainly significant concerns about what would happen with the technology post-COVID. And you could argue that we rush to get these applications out into the field. We want, to be able to fight back the pandemic, and we all want that. But the problem is that the genie is then out of the bottle. You can't put that back. And whether that's in the diagnostic and health applications or indeed in track and trace, that the AI is then ubiquitous. It's all around us. And I'm going to mention a couple of things around that now. But certainly as far as COVID is concerned, I think the rush to get AI applications out, developing AI applications which are big data applications on small amounts of data and small amounts of data which are not representative of the situation which we're all facing, is a deeply flawed proposition and brings a lot of questions and a lot of concerns. That takes me to the broader thing around AI. I have seen many applications of AI where I'm deeply impressed by the technological development and the way the AI has been applied. And I can be both impressed and concerned. I'll give you one example. A couple of years ago, I saw an application being presented by a Chinese academic who'd been working in collaboration with a Chinese company. And the application uses the dragonfly eye algorithm. For those that aren't familiar, there are many, many applications of AI which mimic nature in one form or another, whether they're mimicking human reasoning or other biological and natural evolved solutions to particular kinds of problems. And the dragonfly algorithm takes the idea of the dragonfly's eye being a compound eye. It can look at many images and it can assimilate them. And so it's a vision processing algorithm. And in this particular case, this algorithm is taking images from a variety of different sources, not always with permission, by the way. So CCTV, from social media, but also from sources such as mobile phones and even smart TVs and your laptop. And this algorithm is doing facial recognition. Colleagues might be aware that there have been quite a lot of concerns lately about how facial recognition is used, not only in terms of its the ethics and issues of privacy, but actually issues of things like bias. There have been a variety of applications of which involve facial recognition, which have caused deep concern around their bias towards particular ethnic images, for example. So this particular application in China, it impressed me greatly because of the way the technology had been used. Back in the 90s, when I was doing my early work, trying to do facial recognition from one static image offline was a hard task. And we all recognize now that facial recognition is standard technology in mobile phones, and it's all around us in all sorts of very positive applications, including things like security in airports and so forth. So, facial recognition can be a good thing. This particular application recognizes 1 million human faces in 3 seconds in real time. Now, that's an incredibly powerful application of technology. And I watched with great interest when this presentation was being done, and very, very, impressed by how the technology had been developed and the power of it, but also deeply concerned as to why was it being done. And I think that kind of brings me to the point of the kind of concluding point of this presentation, which is this. I think there's an argument that AI has become so ubiquitous and so powerful that, much like genetic science had to face 20, 25 years ago, some very profound questions about the future of the field. And indeed, in genetic science, some of the questions led to a lot of self-regulation, but also governance and even laws being put around what genetics and genetic scientists could or should do. And that's my point. My point is now that every time we use AI, we need to be thinking very carefully about how we're using it, about the benefits we get from AI, but also what the potential disbenefits are. And because the AI has become so powerful, the fact that you can do something doesn't mean to say that you should. And at the very least, if you're going to, you should be thinking very carefully about whether or not there are unintended consequences down the line. I've seen a number of instances over the last year or so where you might argue that that is a moral and ethical imperative, but it's become a commercial and financial imperative for businesses, because those who get it wrong discover you can't bolt AI ethics on afterwards. You simply can't do that. And what will happen is there'll be a penalty paid by businesses who get the application of AI wrong. So thinking very carefully about whether or not you should do something using AI in a particular way, what the connotations are, and then how you can do it, but do it right, I think is a real imperative. So thanks very much for listening. I know we've got other speakers and then we want to leave some time for questions and answers. So I'll hand over back to our presenter.
Hello there. Thank you very much, John. That was absolutely incredible. And I must ask you later on about your guitar collection. So if you are watching this and you have some questions for John, please do pop them in the chat. We will address them at the end in the Q&A session. There was a key point in that, John, where you mentioned why something was being done. And actually, that leads really nicely into our next speaker. So we have Professor Hassan Ugail, who I had the pleasure of meeting at Leeds Digital Festival earlier on in the year. So Hassan is Professor of Visual Computing at the University of Bradford. University of Bradford are one of our platinum sponsors today, and he will be discussing explainable AI. So I think that's a really nice lead in, and I will hand over now. So thank you very much and welcome, Professor Hassan.
Thank you. Thank you, Lucy, for the invitation and also for this great organizing this great conference. Much of it is actually virtually. I'm at home actually doing this presentation, which seems in some way kind of fantastic. But also I want to kind of, before I start, I want to kind of say thank you for Professor McIntyre also. So putting this into context, and I think the points that you've raised are very, very important indeed. And I might be actually reiterating much of what you've said, I think, in some way or form. So my name is Hassan Ugail. I'm a professor of visual computing. I work at the Center for Visual Computing at University of Bradford in the UK. So I've been actually working in the AI space on and off probably over the last 20 years or so, but it's actually not AI. I mean, as you would know, it's kind of, I'm a trained mathematician turned into computer scientist. So deep inside AI, the techniques, the methodology is actually computer science and statistics, and especially mathematics. So I've been kind of involved in AI space a bit, but more particularly, more recently, I've been actually working on face recognition, which Professor McIntyre also highlighted. So I'll be talking quite a bit about face recognition, because I think it's an important kind of example to highlight some of the advances that we have actually made in AI, and also some of the pitfalls, some of the dangers of actually applying AI and using AI without understanding it. And this is exactly what I want to kind of explain to you. So I will start with an interesting example. So if I show a face, now this is a face. Now, if I show a face like this, and I ask you who this is, you might be able to somehow guess this person. Now, you might, if I give you a hint, you might say, if I give you a hint, is this Marilyn Monroe? You might say, yeah, probably. There's some characteristic of Marilyn Monroe in this face. Now, if I put Albert Einstein in there, you might think actually Einstein is also in there, because in fact, this is an AI-generated face, which is actually a blend of the two. So the interesting thing here is, if I did a face recognition, a standard face recognition, which we should use in immigration scenarios or other scenarios, if I actually applied a face recognition algorithm on this, and then see that how similar it is, the middle face to the two faces, Monroe and Einstein, what I'm getting is very interesting. So it's 81% Monroe, 86% Einstein. But between Einstein and Monroe, there's 41%. So obviously, a face recognition will fail if you put it into the two faces, Monroe and Einstein. But if you put this face, it will say this is Einstein as well as Monroe. So this becomes an interesting question, an intriguing question, because if Einstein and Monroe are alive today, they can have one single passport that they can carry around. If this passport gets approved, by the way, if the process goes through, if this gets approved, they can carry this around, and Einstein can travel using this passport at the same time Monroe can travel. And it doesn't matter that it's regardless Einstein. It can be you and me. It can be anybody. So if we can do this process, we can actually basically fool an AI system or a face recognition system in this process. So this becomes kind of worrying in some senses, because this is being integrated into many forms, and face recognitions everywhere, and it's very, very powerful as well. So as I mentioned, AI has actually accomplished amazing feat. Again, here's another example to actually explain how powerful this AI is. This is an experiment that we have been doing in our lab. We are looking at partial face recognition. So how powerful are face recognition systems based on partial data? Say it could be a CCTV, grainy CCTV image of somebody's eye. Now, if I present these two images to you and say, is this the same person? You probably might struggle, because you don't know, because I mean, this is two different faces or parts of the face. In fact, humans are very good in recognizing faces through the eyes. But I think people will actually struggle to identify whether this is the same person. In fact, AI, our system, actually identifies this to be the same person 80% of the time. Anything above 70% means it's a match, it's an identity match in our system. So that shows how powerful the system is in actually recognizing faces in many instances. I want to also talk to you a little bit about some of the kind of high-profile cases we've been working on using these face recognition systems. So I want to give you an example. So this particular example is to do with the Salisbury poisoning in 2018. You probably will have, it's an international story. So one day I received an email from Bellingcat, the online investigator, with these two images. And they asked me the question whether this is the same person. Now, it wasn't too difficult a task for me, because all I had to do is run this through my face recognition system, and then my face recognition system told me around 90%, on the high 90s, that this is the same person. So obviously, it is the same person from a facial recognition point of view, and we were able to kind of solve this problem. In fact, these the two images here are presented as two individuals with two passports, holding two passports, but they're the same person. So the point I like to make is that these systems are very, very powerful, and it can be used for good to identify criminals, to solve crimes and things like that. But also, there are things that we need to really understand in this, I think, before we go any further in actually creating these complex systems. So the point here is that many people talk about AI. I think people need to also understand what AI does and how AI has evolved over the years, and what is it actually is doing. Machine learning, people talk about, there are different terminologies: machine learning, artificial intelligence, neural networks. So what are these? And I think it's important for us to kind of understand that deep inside a little bit, to be able to kind of make judgments and utilize it in a good way. So modern AI, I mean, AI has existed for 50 years or more even, but modern AI is really about deep learning. Deep learning, I mean, it's a keyword that many people talk about, and many people know about it. So deep learning is to do with actually understanding how human brain works, or the neuron structure in human brain works, and utilize that in a machine form. So for example, if I show a 3-year-old an apple, now the 3-year-old will learn about the apple very quickly. I just have to show probably just one apple and say this is an apple. Now I don't have to show a green apple or a red apple or any other apple, any kind of, I can just show one apple, and the 3-year-old actually understands what an apple is. Now that's a very powerful way of actually understanding about it. What the 3-year-old is not doing is actually classifying apples from green apple to red apple. What the 3-year-old is understanding the actual apple, the characteristics, the features, the texture, and things like that. Based on that, the 3-year-old actually understands what an apple is. Whereas the machine does it in a slightly different way. So I think this is where we need to start also understanding how the machine does it. So So that's how kind of deep learning essentially works in a nutshell. But if you go, it's, as I said before, it's actually based on the neuronal structure of the kind of human brain, as pointed out here. And if you think about it, basically it's a black box where you feed in data, and inside the data there is a system which essentially optimizes these weights and inputs and things like that, these weights, and then essentially it creates a structure. Now this goes back to 1950s, and people have actually utilized this idea to actually create complex systems. So that's essentially kind of how it works. Now, this system has been existing for a long time, as I said before, but 2012 was a good year for deep learning or artificial intelligence. I think it's from 2012 on, people have really started talking about it, because there was a challenge where ImageNet actually solved a huge challenge of 15 million labeled images, 22 categories, and they were asked to actually recognize, create an algorithm to recognize those images. And it was a deep learning algorithm. It was Jeffrey Hinton's team who did this piece of work, and the error rate was 15.3%, which was never heard of at that time. And it was a great time for deep learning and AI, and that's how it all got kind of started. And everyone is talking about deep learning. Essentially, if you talk about AI, it's deep learning. So that was good. So how does I'll just put back again, how does deep learning work, as I said before? So I'll take the example from faces. So here's the example. So what you do is you throw these data, if it's face recognition, you throw loads and loads of images into this thing, which is a structure you can imagine. So you throw different types of images. So in the case of face recognition, you keep throwing these images, and it goes through different layers, and it identifies the face. It actually looks at the color space, the texture space, various statistics on the face, and it actually classifies the face very accurately. In fact, in this particular case, each human face is represented by 128 floating point numbers. 128 floating point numbers are enough to actually represent each human face, up to identical twins in some sense. So in a sense, it's very, very powerful. But there's a deep question here. How did they come up? How did the algorithm come up with those 128 numbers? And what are the actual significance of those 128 numbers? The answer is nobody knows. It just comes up with these 128 numbers, and it's very good. In most of the experiments, 99% of the experiments that you do, it actually comes up with accurate answer. So does that make it accurate 100%? No. So, and also, do we actually know what these 128 numbers are? So those are kind of questions that actually stays. And we have done this sort of work where we looked at partial faces, where we're looking at, as I said before, how different parts of the face actually reacts to the face recognition. And we found out that, only top half or half of the face is actually enough for us to actually recognize somebody purely. It's, as I pointed out in the previous example. And it's very relevant to this day, because we are working on this sort of data now, where face recognition needs to be kind of reworked so that faces are recognized using masks too. So the point is, we have a system like this, and it's not. This is kind of AI, and it's not fully transparent, because there's a black box there. There's a lot of things that happens in it, and the questions is, how does the learning take place in there? What type of learning is it? I mean, surely it's not the way humans learn, because it goes through certain strategies and things like that. It doesn't actually. So it's not how humans learn. And how does it actually decide on these various functions in this black box, which is not known at the moment? So there is a big question mark in terms of kind of the transparency of this black box. How do you do it? Here is a very simple example. So in this example, there's a panda from a huge image set, and it is 57.7% confidence, this particular algorithm, that is a panda. So all we do is we add a small white noise, or some sort of a noise, just basically mix those two pictures together, and then output comes a visually recognizable panda, obviously, but in the case of the algorithm says 99.3% confidence level is a given. So you can see, we don't actually know how this algorithm actually worked this out. Clearly it's wrong, but all you added was a simple basic image to the original image, and it goes all wrong. So these are questions, I think, that we need to kind of think about it. Here's another example from a very well-known face recognition algorithm called FaceNet, which is available on the internet. You can download it, you can use it. If you put in these two images, obviously these are not the same people. Oh, okay, they are related very much. But if you put in those two images, the FaceNet will come as 85% similar both. So a face recognition system will actually fail in this case. So these are kind of key questions, I think, that we need to kind of understand and also explain. So the current AI structure or the deep learning structure that we call the AI is this. You have an input, and then you have a black box, and inside the black box there are many things that you need to explain. So the ML model is in the middle, and then you make a decision. So what happens in the ML model is actually not. So we need to actually open this box and try and understand where. So there are the proposed model for this is you have the model, and then you have an explainable component on top of that. And after that, you make a decision. So this explainable component needs to come in, and people are already started talking about how and what form this explainable model will be. So the explainable model itself should say why and how. Are we trustworthy? Is the success and failure profile? What is this? What is the error correction? So all these questions needs to be ticked before we can actually say this model is foolproof. And I think this is one direction where AI is heading. And I think we will be actually doing quite a lot of technical work as well as other important work in this area of explainable AI. I didn't want to talk too much about the actual methods because this is not the place to actually talk about technical stuff. But I think it's important for us to highlight that model creation and that standard input-output decision is not enough. We need an explainable model on top of each of the models. So every face recognition algorithm must come up with an explainable model. Every diagnostic system that we use must come up with an explainable model, which is easier to understand and inferable by humans. And I think that's where I would stop. Thank you very much.
Wonderful. Thank you very much, Professor Hassan. That was absolutely amazing. I really like the analogies that you pulled there between a 3-year-old learning about an apple and a computer, and then also the decision module on top of the technology, the XAI. I think that's super interesting. I cannot wait to Google more and speak to you about it. So everyone, if you've got questions for Professor Hassan, please do pop them in the comment section and we'll address them shortly. But now we move on to our final speaker. We've got Steve Caughey, who is the director at the National Innovation Centre for Data. And his talk is all about better data analysis today and AI tomorrow. So over to you, Steve. Thank you.
So thank you for the introduction and welcome everybody. Thank you for making the journey. I know some of you have had to travel a full 20 steps from your living room to the study. So thanks for doing that for me. You can throw my slides up now if you would. So my name is Steve Caughey. I'm a professor of practice at Newcastle University, and I'm the director of the National Innovation Centre for Data. And I'm going to talk to you today about better analytics today, AI tomorrow. So most of what I'm going to say is about the National Innovation Centre for Data, which is a fantastic new facility for the North. But I'm also going to draw out some of the lessons that we've learned from our experiences of working with lots of public and private sector organizations over the last couple of years. So let me just put this into display mode. Apologies. So the National Innovation Centre for Data is here to help organizations get the skills that they're going to need to get insight from their data. And we do this in a very practical way by working with organizations on real world projects, using their own people, their own platforms, and their own data. So before I go into what we actually do, why are we here? Why do we need a National Innovation Centre for Data? Well, you'll be seeing graphs like this probably constantly over the next couple of days, but a lot of organizations are drowning in data. Their executives tell me that. The amount of data that's now coming into the organization from social media and from software systems and sensors is just flooding into the organization. And it's no longer sufficient to just take that data, drop it into a tool like a spreadsheet and visually look at the charts and the tables that are produced. The volume, the variety, and the velocity of all of that data mean that you need a combination of mathematical and statistical skills to let you sample data effectively, combined with scalable computing skills to let you crunch through enough of it to make sense of it. And the people who can do that, the data scientists, are in very short supply. The few that we produce are gobbled up very quickly by the financial houses and by the global vendors. And so many organizations, even large organizations, cannot get the people with the right skills that will provide the insight from data. And that's immensely frustrating for the management teams in those organizations, who are very aware of the fact that there's a huge amount of information in all of that data, insight into how their operating processes are running, insight into their clients and their customers that would enable them to create new products and services and also reduce costs. So immensely frustrating. So what can organizations do? If they can't buy people in, can they outsource? Well, that's problematic, because if you outsource control of your data, you're in hock to someone for a long time as you continue to look for insight. But more importantly, so much digital innovation today is on digital rather, and is supported by an understanding of the data that the organization has. So if you outsource control of your data, you're outsourcing control of your innovation. And that's probably a mistake, because the innovators who will help you solve your problems are probably people inside the organization who understand the problem domain and the data sets. So if you can't buy the people in and you can't outsource, what does that leave? Well, it leaves you with upskilling your own people in situ. And that's what the National Innovation Centre for Data is here to do. So why was the National Innovation Centre for Data awarded to Newcastle University? Well, we're good at data, is the simple answer. And universities typically do three things. They do research, they do teaching, and they do some form of engagement. Russell Group universities usually concentrate here, then your universities perhaps here, and usually this is a poor third cousin of everybody. At Newcastle, we're good at all three of those areas. We are world leading according to the Research Excellence Framework, the government's measure of how good you are at these research, and that the last one was 2014. We're full members of the Turing, 100 million in research funding raised. We're good at teaching. We have a gold award in the last Teaching Excellence Framework in 2017. We have a Centre for Doctoral Training in Cloud Computing for Big Data, with about 50 PhD students at any one time working in this space, and some other CDTs as well. Great new masters producing 60 students a year, and undergraduates with a strong focus on data science as well. On the engagement side, we're particularly proud of the fact that we've worked very hard to engage with the public and private sector, to the extent that we are ranked as #1 in the UK for the research impact in computing science, beating Cambridge into second place, as I always like to say. So we're good at all three of those areas. And in addition, at Newcastle, we're particularly proud of the fact that we have built a core team that supports all three of those areas and connects them together. And what that team does is it encourages research, which feeds into great teaching. And it's the great teaching which produces the people who go out into the public and private sector and create an impact. And if we're doing this right, then engagement with those organizations means that they will tell us what they need next from research and what new skills they will need next. And we can drive this innovation cycle around. And this is particularly important in the digital and data space, because things change so quickly that unless you build this feedback loop into what you're doing, your research and your teaching gets stale very quickly. And so we have a somewhat unique, we feel, approach to how we do this across those three areas at Newcastle University for data. So the Innovation Centre itself is a £30 million investment in data. 15 has come from central government, matched by 15 million from Newcastle University, and 20 of that is going into a beautiful new building that I'll show you in a minute, along with 30 million from the National Innovation Centre for Aging, who share the building with us. And they're mostly focused on products and services, mostly in the digital space, for the aging population. So there's a lot of synergy between what we do. We're trying to build a unique facility that will bring together the public sector, the private sector, academics, students, citizens, in order to learn more about the importance of data and what you can do about it. We do three data-related programs using a unique set of assets that we have. We run an insights program, which is aimed at management teams, sector specialists, technical specialists, inspiring school kids, exciting citizens, and that's all run from this fantastic new building on our site at Newcastle. And of course, at the moment, most of those events are being run through Zoom. The second thing that we do is that we run a connections program that helps signpost organizations to people who can help them with their data. Those might be vendors, it might be consultants, it might be training, but probably most importantly, it connects organizations into students who are looking for internships, projects, and eventually employment. And although right now we're focused on the Northeast, we intend to be a clearinghouse for students with those skills across the UK. And in fact, we're finding that in the Northeast, getting students in at that level to do internships and projects will often result in them getting employment and therefore prevent the data brain drain to the South and to the US. The third thing that we do, and the primary thing that we do, is we run data skills projects intended to transfer skills into organizations. And I'll explain that in a minute. And to do this, we use a dedicated team of PhD level experts. That's rather unique in universities. Usually, people who are employees of universities are focused on research and teaching and then do some engagement. Our team only engage with organizations. They're not measured on research or teaching. So it means they can be really dedicated to providing results for the organizations we work with. And at the end of all of this process, the hope is that clients who work with us have a return on investment by helping solve a real problem. They might have some intellectual property. We make no claim upon any intellectual property developed. But above all, they have a new set of skills that means that they can solve problems for themselves going forward. This is our beautiful new building that we unfortunately can't really get into at the moment. This is the prize we could have won. Fantastic public spaces, including a wonderful TED-style theater, seminar rooms, workshop spaces, very nice social spaces and commercial offices. Like I say, we moved in December or so, and we were back out again by March. So it's sitting there unused at the moment. Breaks my heart. The building, which is this sort of triangular shaped one right in the middle of the site here, is on the Helix site in Newcastle. And this is right in the city centre. St. James's Park is just here. There's the central station. The city centre is over here. And this site is being jointly developed by Newcastle City Council, Newcastle University, and Legal in General. And what they're building between them is a mini smart city in the middle of Newcastle. So it's 24 acres, £350 million investment thus far. And from a data perspective, the academic and commercial buildings on the site are packed full of sensors. The spaces between the buildings are packed full of sensors. So we're measuring water flow over the site, electricity, people's movements, the usage of buildings. And a subset of the 400 plus residential properties on the site will also be heavily sensored up to help us do research into things like assisted living. So all of this data from this mini smart city flows to the researchers who work out of this building here, but it can also flow to the commercial properties who are attracting onto the site to experiment with smart city products and services. And then the hope is that if those products and services look interesting, with the support of the university and the city council, they can roll it out into the broader city and the city region. So a very exciting development, and we often think one of the best kept secrets in the UK, although I don't know why. The team are primarily PhD level experts. We have some masters as well. Experts in maths, in stats, in machine learning, in data engineering, in data visualization, and so on. And the team come in and out of projects depending on when those skills are needed. And the projects that we do have to be real world projects. So when a client approaches us, they have to have a real problem that has management attention, that has a measurable return on investment. And then we ask the organization to apply their own team to work on the project. Our team of experts sit behind and beside them. We steer them and guide them, give them hands-on tutorials and seminars, show them new approaches, new tools, new techniques, either to individuals in the organization or to broader groups. We will dive in and get our hands dirty to help, but that's to demonstrate how we would approach the problem. So at the end of a 3 to 6 month project, you get these people at a heavily subsidized rate, thanks to the government. You end up with hopefully a solution to your problem, but much more importantly, the project team have picked up new skills that means they can go on and solve problems for themselves. And here are the sorts of people that we work with. The first two rows are our typical sort of clients that we work with. They tend to be the larger public sector and private sector organizations because they have the capacity to take these new skills on board. But we do work with SMEs. We have a program to support SMEs. If there are SMEs that have particularly exciting projects, we also participate and join in with those. The businesses listed on the sort of third and fourth rows here are people who are often our partners. So these are the people who are very interested in engaging with us because we're helping to stimulate the market and excite these organizations around the importance of data. And then the other organizations are partners who come in to engage with us and assist. One quick example, a company called LKQ, who are the world's largest distributor of car parts from the manufacturers down to the garages. They're a Fortune 500 business, although you'll never have heard of them. They worked with us on a project for 6 months a couple of years ago. Very exciting project, as reported here by the head of data analytics, but probably more quantitatively, a significant return on investment. We can't quite say how much, but it was a significant return. They were shortlisted for Computing Magazine's 2018 Big Data Award. Didn't win it, but came close. And they became that organization's European data analytics team. And they supervised rolling out the same process in 22 countries. So this is an example of what we're trying to do. We're trying to help organizations bootstrap data analytics capability by solving real-world problems. So in summary, what we're trying to do is we're trying to build a beacon for data innovation, a temple to data. A place with world-class facilities and services under one roof. Fat lot of good that does us right now. We're all about delivering these next generation skills into the organization. And if we can do that, then the people who pick those skills up, they can be the ones who then go in the public and private sector and deliver innovation. So that's a quick spin through what we do. Now just one slide on the lessons that we've learned. So one thing is, especially for data professionals, it'll be great to hear, is that demand for help with data is immense. We've barely talked to a company over the last couple of years that hasn't asked for help. We've engaged with 400 businesses, and we have 75 sort of actively engaging with. Almost every business from the smallest to the largest needs help with data and is struggling. Management is often bought into the fact that they need to do something, but they're often confused as to what their first step should be. There are lots of unknown unknowns, is the way people often put it. They don't know where to invest. They don't know. They're frightened of jumping into bed with a vendor or a consultant because they'll get locked in and be sold stuff. They don't know which skills they need, and they don't know what problems to address. So management themselves often need a lot of help. Very few organizations are AI ready. So I know this is an AI conference and maybe this is a negative story here, but lots of organizations tell me how excited they are about AI. But when I actually go to engage with them, it turns out they've still got lots of paper processes. There's a lot of data engineering to be done, and they're a long way off. I went to an NHS trust a while ago to talk about using AI for patient bedside monitoring. Great conversation, very exciting. And then when I left the room, I was nearly knocked over in the corridor by somebody pushing a trolley that was 2 meters long, 1 meter high, and 1 meter wide of paper from one department to another. So there's a lot of work to be done in many organizations before they're in a state to actually exploit AI. Most are struggling to hire. Getting people in is really very difficult. So our lessons for that we pass on to organizations is you should start small. Find a real world problem, so low-hanging fruit, and experiment. Begin to explore it. That will teach you what you need in order to progress, what skills you need, what tooling you need. And we can help. National Innovation Center for Data is set up to help with those sorts of pilot inspirational projects. And incremental improvements are what most organizations need. Many organizations that we deal with are dealing with spreadsheets. And when they finish, at the very least, we can give them a better spreadsheet. That actually can make a significant difference. But also it excites people and shows them that returns can be made by investing in this space. And so then they begin to explore other technologies and take steps forward. So better analytics today for those organizations. And if we can achieve that, then maybe sometime in the future, we've got an opportunity for AI. Okay, thank you very much. That's, I've left us a little bit of time for questions.
Thank you very much, Steve. That was very good. And it's really good to hear about the £30 million investment. actually, and how that's supporting the three areas that you mentioned with the teaching, the research, and also the work with the public sector. So thank you so much for that. I'd like to invite all of our speakers back up to the virtual stage, please. Hello, everyone. Thank you very much. So during that session, we did have a couple of questions that came in. So we are going to present them to you now, starting off with you, Professor Hassan. So when we talk about using facial recognition for good in policing, how do we separate the good from the bad? So, for example, you mentioned the Salisbury poisoning, but then how do we separate that from peaceful protesters, for example?
I think that's a very interesting and good question. So I think what we need to understand is for important police work, whether it's AI or facial recognition in the sense that we have, I think those are important work and they are legally allowed to do that kind of work, which are important work. But whereas taking this technology to the kind of, at a level, at a public level where human rights are kind of, almost kind of not obeyed is a different question. So the point here is, I think that we need to kind of understand these, whether it's facial recognition system, whether it's a healthcare system or whatever it is, what are the kind of standards that we need to implement, and are the standards available there for us to actually use it publicly and openly? I think that is what's not tested, for example, often when these systems are deployed in identifying and cataloging protesters, I suppose. I think that's the difference, but it's nothing to do with actual technology as per, I think.
Absolutely, yeah, and I think that really reiterates your point about explainability and how that can go hand in hand with testing. A lot of things seem to go untested properly these days, but thank you. And just to sort of piggyback onto that one, we have another one. So when you derive an explainable model, and that's a technical model, you demonstrated that in one of your slides, is there a graphical tree diagram that someone that's not technical could easily understand or find useful? And I guess that's open to everyone as well.
Do you want me to say something about it first?
Yes, please do.
Okay. Yeah, so I think it's important for us to understand how these ML models, machine learning models, are created. So essentially, what you do is, it's a bit like I see a bit like a small human brain, where you feed in data. So you can feed in I don't know, whatever it is that you can feed in text, you can feed in images, you can feed in other things, but you've got some sort of a thing saying, okay, what it's doing is it's essentially just classifying things. It's not actually learning about things. It's actually what it is doing deep inside is actually classifying things. So the classification problem, then what we want from this classification problem is the intelligence. And that's where we all go wrong. We think this thing is very, very powerful, but it's actually not it's not extracting pure knowledge as we humans do. The example I gave about the apple and the 3-year-old, when you show that, I think the 3-year-old actually understands that it's an apple in that context. Whereas when you show an apple to the ML algorithm, it just sees an image, it's pixels, and all it's doing is classification. So the models are kind of, that's how the models are created. And that is a technical model. You're right, that's a technical model. And also the model depends on the data that you feed in. So if you feed in wrong data, you will get, rubbish out, obviously. So that's the problem with kind of, the biases that are introduced in face recognition, for example. Most of the face recognition algorithms are trained using predominantly white faces, as data points. And what you expect, if you put in an ethnic minority face, it's going to say no, obviously. It's nothing to do with the actual algorithm. It's the way we train it. And this is the important point I want to make. We need to actually understand it's not the fault of the algorithm. It's us, actually, because we're training it wrongly and we're expecting the wrong output from it, I think.
You're absolutely right. It is the humans, and that's why communication in teams is so important. Does anyone else want to add to that?
I would just add that Hassan in his presentation talked about building trust in AI. And that was a kind of big part of what I was talking about too. Explainable AI is not the same as trustworthy AI. Explainable AI is one step on the journey towards trustworthy AI, because if you can understand what an AI model is doing, which therefore you can get an explanation as to the map between its inputs and its outputs, then that helps you to understand how you got there and perhaps correct any deficiencies. And there are deficiencies in AI models all over the place, and some of them are quite profound. That thing around biases, a great quote. These aren't my words, but I like this quote a lot. An algorithm is just software with an embedded opinion. And so the idea that what we do is code AI models or build AI models, which then learn the nature of the data we give them. And if the data is biased and we've encoded the AI model in a way which embeds opinion, then naturally what we're going to get is at least a biased output, if not indeed an inappropriate output. And we're seeing that there are quite a lot of AI models which bring not just bias, but really inappropriate outputs. And so working back through that and understanding that we're kind of building appropriate ethical models and governance frameworks around the development of AI, which includes the data you use to train AI, is extremely important.
Absolutely. I think you've just coined the term data deficiency there.
Absolutely.
I think it's also worth saying from a business point of view, there's an opportunity for lots of snake oil to be sold here. The opacity of what's being sold, and people are expecting AI to ride to the rescue in many cases, and I think there's a danger they'll be sold a black box that produces some output, and you've no idea how it got it. And by the time you discover it's wrong, your business can be ruined, right? So that's why it's important, I think, to have skilled people inside the organization who can at least make an effort to assess what's actually happening inside the black box.
Absolutely. Thank you very much. I've got a question for you, John. So in your talk, you mentioned that a lot of these AI and COVID applications are not based on sound data. So what do you think they are being based off? Is it of previous pandemics, which is, of course, largely out of date, which is a bit of a problem and not exactly representative of today? So yeah, what's your take?
Yeah, so the answer is in part yes. So previous pandemic data and models have been used to create what you call kind of standard epidemiological models. But then you get, of course, presented with the actuality of what's happening in COVID. And then that's where you start to see the flaws. The other thing is that where you've done, where models have been built using relatively small amounts of data from the past, and some of it is theoretical simulation data, and some of it's real data, but relatively small. And then you're in the realm of seeing, millions and millions of people infected, and indeed, millions dying. You're in a completely different realm. So some of the big data modeling that was done, which was the base epidemiological model here and indeed in the US and elsewhere, if you go and look at what was done in Canada, for example, that shows you that the model, and I think what's going to happen, of course, retrospectively, a lot of hindsight, there'll be a lot of learning from this, and hopefully those standard models will be much more robust. But what's been exposed is the flaws in that approach. And I think some of that is the inevitable consequence of dealing with a new disease. This is a disease which had aspects to it which were not included in the modeling. And therefore, how could the models possibly cope with them?
Exactly. No, you're completely right. And thank you for the response there. Steve, I've got one for you. So your talk was obviously about data today, AI tomorrow. One of the things that you mentioned was the use of sensors in some of the buildings in the area. And what I inferred from that was you're collecting lots of data, but in order to improve a process potentially or a building. Would you be able to tell us a little bit more about those sensors?
Yeah, so I can't claim any of the credit for this. There's a group working out of Newcastle University called the Urban Observatory, and they have the UK's largest collection of real-time urban data. We think it might even be Europe's largest collection of real-time urban data. And they've been doing it for many, many years, sensors embedded all over the city, collecting traffic data, people's movement, and so on. In addition to that, because it's a new site, all of the buildings come with sort of building information systems, which collect vast amounts of data and then throw it away. So all of these systems are designed to measure everything happening in the building, but actually nobody's actually taking those feeds and doing anything real with it. So that's one of the things we're plugging into to try to find, are there ways that you can actually much more actively interact with the building and the people inside the building to make it a more efficient place to live and work.
Oh, wow, I really like that. I was really captured by that part of the talk. And thank you so much for answering. We've got another one that's come in. I think it's for everyone. So actually, I see this quite a lot. So there's a number of frameworks that are developed for ethical AI, but there does seem to be a number of competing ones. Do you have a preferred framework to apply to projects in order to safeguard against bias and abuse?
I'll just say a little bit about that. It's true that there are many frameworks. So there's work being done here in the UK. There was a House of Lords Select Committee that was looking at the whole thing around AI, and in 2018 brought out 5 kind of very, very broad-based guidelines, which I'm friends with Lord David Putnam, who was a member of that committee. And I think even David would admit that they were kind of a bit motherhood and apple pie and a bit mushy. We want AI for good. If anybody wants to go and read them, by the way, 3 of them or 2 of them seem to be very similar to Asimov's laws of robotics. So kind of shows you the technical background. But yeah, AI not doing harm and all that kind of stuff. I think likewise, there's been White House committees, and there's now a European Commission program on this. I think the key for me is, yes, there's a lot of work being done, which is setting out sets of principles. But for people, particularly in the commercial sector and industry, who are going to be developing or using AI, the question is, fine, we want to do AI for good. How? What do we need to do? What do we need to make sure that we don't do? Specifically in answer to the question, whilst it's not for me to advocate a particular approach, but the IEEE is doing a lot of work on developing kind of a standards approach to the development of AI, and I would heartily recommend a good look at that, because I know that's very robust work. And the other thing I'd do is have a look at the work of a variety of different organizations on the functional role of the AI ethicist. So not someone a bit like the risk manager in an investment bank or the health and safety person at work that you try and avoid or pay lip service to, but actually taking somebody who has a functional role in looking at the ethical connotations of the AI you're developing or the way you're using AI, and having that person as a functional member of the team who's actually embedded in the development or use process and can help you to understand it. I think that's a great way forward.
Definitely very important to have that embedded role in place. Would anyone else like to add to that before we need to wrap up?
Just a quick comment that I often make in these situations, just a word in favor of algorithms. They're getting a very bad press at the moment. The thing about an algorithm is you can dig into an algorithm and look at it and uncover the bias. Try doing the same thing inside the head of a judge or a police officer yeah.
No, you're absolutely
right. Yeah, I think that's a very good point. So whenever the algorithm makes a mistake, we blame the algorithm. Whereas I think we should be blaming a human who constructed that algorithm, or a human who's trying to get in some sort of a desired output which the algorithm doesn't understand. So I think that's important. But also I think on the ethical front, what's happening is, in my view, the ethical front, they're trying to catch up. The technology is advancing so far. I mean, for example, it's only like 5-10 years. The facial recognition system has changed. The technology has changed. I mean, John will know probably the papers that he receives. It's all about deep learning and everything. But 5-10 years ago, it's nothing to do with that. Probably some other thing. So it's actually the entire landscape has changed. The technology has changed, and the AIs and people on the AI on the data governance side are actually wondering what's going on. Companies are actually trying to use this technology, and obviously they want to put profit on top of things as well. So that doesn't help either. So I think the main point is we are lagging behind on the standards and the techno and the ethics, and we should really be catching up with that, I think.
Yeah. If I just add to that, by the way, just as an example, I think there are a number of kind of apocryphal case studies now on the development and use of AI, which hasn't embedded the kind of ethical considerations, and then it unravels badly. And I'd commend colleagues, if you haven't already done it, have a look at the story of a company called Clearview AI in the United States, who developed a facial recognition system to be used as an investigative tool for various police and other agencies. And they scraped 6 billion images from social media, formed that into a training database, and parked for a moment the idea that means that, as I am prone to do, take a picture of myself in a pub with my mates and stick it on social media, and it's now kind of potentially in the data training base for an AI, and could make me a person of interest in a criminal investigation without my permission. So there's a thing there. But look at the mechanisms by which Clearview created that database and then developed the tool, and then look what happened. And what you see is that I think is a great example of, as I said in my presentation, this is no longer just a moral and ethical imperative. It's a corporate, commercial, and financial imperative. Get it wrong like Clearview did, and what you see is your product will be dropped by your users. About half of the customers drop the Clearview system. That in turn led to IBM and Google walking back what they're doing with facial recognition. So getting it wrong is far, far, far worse than spending the time and investment getting it right.
Thank you so much. And also thanks for the resources that you mentioned there. Hopefully we collect them from you and post them on our social channels later. I'm afraid that's all we've got time for, but thank you so much to all of our speakers for being part of the summit. It's been brilliant to have you. And to our audience, again, thank you for attending this track. We will be back at 1 o'clock with some more sessions, so please do enjoy a break. But virtual round of applause to our speakers, and thank you very much. See you very soon. Bye-bye.
Thanks very much. Bye-bye.